Okay, first I'm going to start with 15C, numbers 7 through 9. I just heard that some people had some trouble with the homework. I'm really sorry I wasn't there today. It's 2y is greater than 3x plus 6. So rewrite using slope-intercept form. That means we want it as y equals mx plus b with nothing in front of the y. So we have to divide by -2 to get y by itself. When we have an inequality and we divide by a negative number, that should be a red flag for you. Red flag, we got to change that sign. So we're dividing by -2. This will leave us with y. We have to flip that sign because we divided by a negative number. And then we have -3/2 x minus 3. Now we need to graph the inequality. So I have to graph the line, and then because it is less than and not a less than or equal to, that means I need to make a dotted or a dashed line, but I need some holes in that line. So I start with my y-intercept is -3. I'm going to go up 1, 2, 3, and then I'm going to go backwards 2. And then I'm going to go up 1, 2, 3, and then I'm going to go backwards 2. So hopefully that's enough for us. I can't get my computer to do a dotted line, so I'm going to cheat just a little bit. And I'm going to draw my line in, and then I'm going to use my eraser to make it a dashed line. Okay, now which side do I shade on? I can look at that y is less than, and I can guess that it's probably underneath. So I think I'm going to shade down here, but then I want to check a point. So I always like to check 0, 0, pretty easy point to plug in. So if 0, 0 satisfies this inequality, then I should have shaded on the side with 0, 0. So I'm hoping that 0, 0 does not work. So I'm going to put in 0 for y, and I'm going to put in a 0 for x, and I'm going to have 0 is less than -3. Is 0 less than -3? No, because -3 is less than 0. So the 0, 0 does not satisfy the equation. In other words, I shaded on the correct side of the line. So that's how you're going to check that. On your worksheet, I should have finished reading it. It says, will the point 3, -4 satisfy the equation? That means if you put in 3 for x and -4 for y, will that make that true? So let's find out. -4 for y, and then a 3 for x, and then I have to solve. This is going to be -9/2 minus 3. -9/2 is like a -4.5. -4.5 minus 3 is going to be a -7.5. Is -4 less than -7.5? No. So that one does not satisfy the equation. We also, once we had it shaded, we could have plotted the point. So let me do that. If I plot this point 3, 1, 2, 3, 4, it is not on the side that I shaded. So it will not satisfy the equation. So we can do it two ways. We can plug it in. We can use our algebraic methods of doing it, or we can graph it and put the point on the graph and see if it satisfies the equation. Okay, so that was just one example from the homework. If you did that homework and you still missed a lot, please let me know and I will add more and do another video, or we can go over it again, because we have 2 weeks left and then you're going to have a test to take home to do before Christmas break. So, well, I guess it's during Christmas break. Anyway, whenever you decide to do your work, it's going to be due about the beginning of December. So within about 2 weeks after our last class, you're going to have a test that's over all of this. It's going to start with lesson 11 and go all the way through lesson 20. Okay, So I'm just going to go over our lesson from class. Hopefully your sub did a great job. I'm not positive who it was, but I'm just going to go over it really fast and do some of the examples to make sure that you understood it. So we've learned all these ways to solve systems of equations. Now we're going to put them to use. This first example, I have 9 coins in my pocket and they are all dimes and nickels because my 5-year-old's obsessed with pennies, so I give them to him. And then we use quarters to pay allowances, so I always save those somewhere else. I have 65 cents in my pocket. How many of each coin do I have? So we have 2 pieces of information, 9 coins that are dimes and nickels, and they're worth 65 cents. And I know how much nickels are worth, and I know how much dimes are worth. So that's going to be my 2 equations. Traditionally, I'm just going to use the N for nickels and D for dimes. If you wanted to make it a T for 10 cents and an F for 5 cents, I mean, you could do that, whatever variables you want to use. But I know that I have 9 coins total, and those are dimes and nickels. Now, when I put dimes and nickels into the amount of money, I'm going to change it all to cents just because it's easier. I mean, you could make them decimals if you wanted, but that's not as fun to work with. So 65 cents, 65 whole numbers. And then a dime is worth 10 cents. So if I have 1 dime, I have 10 cents. If I have 2 dimes, I have 20 cents. So I'm multiplying the number of dimes by the value of 10 cents. So I'm going to do that with my nickels too. My nickels are worth 5 cents. We have these 2 equations. We have 2 variables. We can solve them any way we like. I don't know if some of you got used to elimination and was like, oh, that's great. For some reason, elimination is just not what I did a lot as a student. And so I always choose substitution. But just for funsies, I'm going to do elimination. So let's see. What if I eliminate the nickels? So I'm going to take this equation and I'm going to multiply by -5 so that I can get rid of the nickels. So when I do that, I have -5 times 9, which is -45, -5 times D, so -5D, and -5 times N, so that's a -5N. Then I just put this equation here. Hopefully that will eliminate one of my variables. If not, then I just need to multiply something else somewhere to make it work out. I'm going to add these 2 equations. So my -5N and my +5N, that makes 0. My -5D and my positive 10D is going to give me a +5D. And then my -45 and my +65 gives me 20. So now this one looks much better. 20 equals 5D. I'm just going to divide by 5. So I have 4 is equal to D. That is the number of dimes I have in my pocket. So I have 4 dimes. If I have 4 dimes, how many nickels do I have? Well, we could plug it into this equation, but this one up here is much easier. So 9 equals 4 plus 5. My second grader does that well. So, you know what? I can't spell nickels. Here we go, EL. Okay, so 4 dimes and 5 nickels. That's what we have. Okay, not too hard. You just have to remember how to do that value of the coins. So I have 15 coins in my pocket, but this time they're all pennies and nickels. The value is 35 cents. How many pennies do I get to give to my son? When I wrote this worksheet, he was 5. Now he's almost 8. So, okay, I know that there's a total of 15 and they are made up of pennies and nickels. They're worth 35 cents. A penny is going to be 1 cent. So I just have 1 times P, but a nickel is 5 cents. So 5 cents for every nickel that I have. Now this one is actually really easy to use with elimination. I could just put a -1 up here on either of them really, but I know that I want to choose this one so that it comes out positive. Okay, and I'm even going to put this one first just because I like, to subtract in the right order. So 35 equals P plus 5N, not that it matters, but this is the way I choose to do it. So -1 times 15 is -15. -1 times P is a -P, and -1 times N is a -N, and I got to put my equal sign up there. Okay, so now when I add these together, 5N minus N is 4N, P minus P is 0, and 35 minus 15 is 20. Oh, it's the same problem again, almost. I'm dividing 20 by 4, so I get that 5 is equal to N. If N is 5, that means I have 5 nickels, that's 25 cents. So I have 35 cents total, so I must have 10 pennies. And 5 plus 10 does indeed equal the 15 coins. I could double check it. 10 and 5 is 15 coins. So that works out. And then 5 nickels, which is what I just said, but I'll do it out loud, is 25 cents. Plus 10 pennies is just 10 cents. So, whoops, I shouldn't have done that. That right here came from the 5 times 5 is 25, and then plus 10. So that's 35 cents, and that works out. Sorry, got ahead of myself there. I'm trying to do it fast because hopefully you paid attention in class. But this is just to go over it one more time if you need that help. Consecutive integer problems. These include whole numbers and their negative counterparts. So consecutive integers could be 2, 3, 4, 10, 11, 12, but they could also be -4, -3, -2. So you could have consecutive integers that are negative. Consecutive even integers would start with a smaller even number and count by twos, 22, 24, 26. Consecutive odd integers begin with a smaller number, which is odd, and then increases by 2, 7, 9, 11. We could also be negative, such as -11, -10, -9, or negative and even, -8, -6, -4. You could cross over the 0. You could have -2, 0, and 2. So you can go from negative to positive. These are still even integers, consecutive even integers. We can represent these by a relationship. We give a variable to the first number. We usually use n just because that stands for number, but you could use x, you could use p, w, you could use alpha, you could draw a smiley face. However you want to represent that first number, but then know that the next number in a consecutive integer situation is going to be that first number plus 1. And the next one would be that first number plus 2. And we could keep going. We could do n plus 3, n plus 4, whichever number in a line that you want. So if n is equal to 5, these integers would be 5, 5 plus 1 is 6, and 5 plus 2 is 7, 5, 6, 7. So they come up in a row. Now, even integers, so let's say that we have 6, 8, and 10. If I give 6 the value of n, then what am I going to give 8? N plus 2, because we had to skip 2 to get to 8. And to get 10, I have to do n plus 4. So if n was 6, then I have 6, 8, and 10 when I have n plus 2, and n plus 4. Now the tricky thing, how would you write consecutive odd integers? I'm going to give the first one n. What comes next? If you said n plus 3 or n plus 1, I'm not sure you're correct. Let's say that we want to do 11, 13, and 15. Those are consecutive odd integers. If n was 11, then what do I have to add to 11 to get 13? I have to add 2. So it's n plus 2. How much would I have to add to 11 to get 15? I have to add 4. So it's still the same as the even ones, n plus 2, n plus 4. It's just that we started on an odd number instead of starting on an even number. So what would the consecutive odd integers be if n equals 23? Well, if we use our formulas, we have n is 23. So the next one would be n plus 2, 23 plus 2, 25. And then n plus 4, 23 plus 4 more is 27. All right, now here's our first problem. Find 3 consecutive integers where 2 times the first integer minus 6 is equal to the third integer. First, start with what are our integers? They are consecutive integers. They're not even, they're not odd. So the first one is n, the second one is n plus 1, and the third one is n plus 2. Now we're just going to write this in the order that we see it. This changing words to equations, in other books that I've taught from, it's like 2 or 3 lessons worth. So just know that if you're struggling with this, just go slowly. Read it more than once if you need to. I just start at the very beginning. Okay, 2 times the first integer. That means 2 times that first integer. Minus 6. I do minus 6 is equal, or just sometimes it just says is. That's your equal sign. The third integer. third integer. Okay, so now we just have to rewrite it with the n's in there. So the first integer is n. So it's 2 times n minus 6 is equal to the third integer. So the third one is n plus 2. I didn't even use the n plus 1 in this equation, but that's okay. When I look at this equation, I realize I only have one equation, but I only have one variable. So that's it. I am going to solve this equation by getting all the n's on one side. I'm going to move this one over. And getting all the numbers on the other side. So I'm going to move the 6 over. Look, I can do it all at one time. These cancel, meaning they add up to 0. These add up to 0. I have 2n minus 1n gives me 1n left. And 2 plus 6 is 8. I've solved for n. Now I go back up to the very top and it says find 3 consecutive integers. So I need to list all 3 of them. If they're consecutive, n is 8. That's the first one. What's the next one? The next one's that n plus 1, or my next number, 9, and then 10. Okay, 3 more examples. Find 3 consecutive even integers such that 5 times the first plus 3 times the third is the same as 7 times the second plus 10. That sounds really confusing. Just start at the very beginning. If they're even integers, I know that I have n plus 2, and n plus 4. Okay, 5 times the first. There's a comma there, so I'm gonna pause there. 5 times the first. This one's the first one. So I have 5 times the first. Plus 3 times the third. Well, I know it's a plus. 3 times the third one. This is 1, 2, third. So that's this one right here. I'm gonna put it in parentheses, and that's important. Make sure you put this part in parentheses when you're writing it out. Is the same as. That means equal. 7 times the second plus 10. Well, I'm going to pause. 7 times the second. This one's the second one. 7 times the second one plus 10. Okay. It's important that it's 3 times parentheses n plus 4 or 7 times parentheses n plus 2. Because that 7 has to go to both the n and the one that you're adding. So 2 or 4. So I'm just going to simplify this a little bit more. It'd be plus 3n plus 12 is equal to 7n plus 14 plus 10. I can add this part together and this part together. I'm going to move up here. So I have 8n plus 12 is equal to 7n plus 24. I'm going to subtract 12 on this side and that side. And then I'm going to subtract 7 on 7n. And that gives me n is equal to 12. Remember to list all of them. They're even integers, so I have 12, 12 plus 2, which is 14, and then 16. All right, 2 more. Find 3 consecutive integers. So just n plus 1, and n plus 2. Just read it in order. 7 times the third. 7 times the third one minus 5 times the second. 5 times the second one is the same as, is equal to 4 times the first plus 1. That plus 1 is outside of the parentheses. It's just 4 times the first, which was n by itself. All right. Out of room here, but 7n plus 14. Take this negative with the 5 as you distribute to the n and the 1. So minus 5n minus 5 is equal to 4n plus 1. I'm going to choose to move the n's to the right side because then they're going to end up positive, and my numbers to the left side. So I'm going to subtract a 1 in here and I'm going to add the 5n and subtract the 7n. So I did that all at one time. Do you see I used opposite signs? This was a negative 5n on this side. Over here it's a plus. This was a plus 7n, so over here it's a minus. So I have 14 minus 5 gives me 9, minus 1 more gives me 8. And then 4n plus 5n, that's a 9n minus 7n, so that's a 2n. And then when I divide by 2, I get n equals 4. So my consecutive integers are going to be 4, 5, and 6. All right, last one. 7 coins made up of dimes and quarters. So I can already get my first equation. 7 is equal to my number of dimes plus the number of quarters. They have a value of a whole dollar. How many cents are in a whole dollar? 100. So 100 cents is equal to 10 cents for every dime plus 25 cents for every quarter. So here's where I like to do substitution. And so I'm going to say that 7 minus Q is equal to D. And then I'm going to put this 7 minus Q in for D right here. So I have 100 is equal to 10 times D, which is 7 minus Q, plus 25Q. I distribute this 10 to the 7 and the minus Q. So 70 minus 10Q plus 25Q. I'm going to subtract the 70 on both sides, and then I'll add this together at the same time. So 100 minus 70 is 30. 25Q minus 10Q is 15Q. I divide by 15, and I get that Q is equal to 2. If I have 2 quarters and 7 total, then I must have 5 dimes. Let's double check that that would equal a whole dollar. 2 quarters is 25 cents. And 5 dimes, whoops, I'm sorry. 25 cents times 2, which is 50 cents. And then 5 dimes would be 5 times 10 cents, which is another 50 cents. And that together is equal to a whole dollar. I will do a class on Friday. I don't think I have anything. So Friday afternoon, I will be online. I will send that link out as well.